And then just to dovetail onto something you had said, and it's really critically important, it's the phosphates that attack the surface of a zirconia restoration. And it's funny that we have to remove the phosphates, so then we can treat it with a phosphate primer, right? So MDP is the critical ingredient that any zirconia primer has. And then you start to say, well, yeah, that's been a long time in the making, if you will, and people have been using those for a long time. But it's not, that's not the whole story, right? I mean, we start to look at the zirconia primer that we started to work on a long time ago. We had customers call, and this is 2010. This is a funny story, not to make this last longer. 2010, doctor calls and says, hey, I'm doing a full roundhouse on a patient, all zirconia. I want to know, how do I bond on the zirconia veneers? And it's 2010. So quickly we go, you don't. And we hung up, right? We don't want to talk to you. And if you do want to talk to somebody about that, you should talk to somebody else who supplies adhesive stuff, because we don't ever want to talk to your attorneys. Anyway, so we started to go down that path, and it wasn't until 2015 or so we said, hey, this zirconia stuff, it's here to stay. But boy, is bonding relevant? Isn't it relevant? How do you approach it? And finally we got down to it and said, hey, all these materials out there just aren't giving you enough bond strength, because we start to look and say, as zirconia moves from the back to the interior, now you need to bond, and it's required. And it is the thinner margins that we talked about before. Somebody wants to do the 0.6 millimeters, you really have to bond those and give them a strong surface. And boy, it took us a long time to take what was on the market and take that past the idea that you just put MDP in a solvent to deliver something. So we ended up blending these materials together and say, hey, now we can get 40 plus megapascals of strength to zirconia, which is really a game changer, right? Because you look at Denton's internal strength, people can argue it, but around 26 megapascals, now you're exceeding that with your bond strength. So we're really, as we see it, allowing that zirconia to continue its evolution and move forward. The other thing that people saw in the presentation that you gave, I think is important to talk about a little bit, is when we look at those bulk fill resin cements that we talk about. One thing that people say, well, I just cement mine in, and that's great, except the inherent strength of a cement's very small, very, very low. It's great at releasing fluoride, and it does those types of things, but that's what the Sensomax does too. We have a fluoride component to help hide that on the tooth. But the one thing that we've always thought, and just being purists as far as materials go, is when you put a cement, and that's going to be the interface between your tooth and your restoration, it doesn't have great wear characteristics, it doesn't have great strength, yet this is supporting this incredibly strong restoration and a tooth structure. We've always felt that having those resin-based cements really gives you a stronger material, and then a more homogeneous and stronger, long-lasting restoration. But that was a great presentation.
Yeah, and going back, what Dr. Detola talked about, how we just love cutting zirconia off, and most of us, if we place a zirconia veneer or crown or bridge, we know that the failure now is not going to be because it fractures, because these guys are so strong, but it's probably going to be because of recurrent decay, and our weak link might be that cement zirconia tooth interface right there. And again, just to stress what regen can do, and Scott, you can add into this if you want. Yeah. But by having that bioactivity, we actually find that it inhibits as a zone of inhibition where the really bacteria can't survive around that margin. And if we can keep the bacteria from attacking our weak link, hopefully we never have to cut a zirconia restoration off.